Okay, so cast your mind back to the previous video where I introduced you to the concept of base 10, which is basically all the numbers we use 0 to 9. I also said that computers, when they talk to each other, use binary code, which is ones and zeros. So how would I use the number 2 or number 3 or number 4 or 5 or 6 or 7 or 8 or 9 in binary code? So if computers only talk to each other and use zeros and ones, how do they use the number 2 or number 3 or number 4 or number 5 or number 6 or 7 or 8 or 9? Let me show you. So 4 zeros is our 0 with what we use in base 10. 0, 0, 0, 0, 0, 1 is our number 1. A computer has its own binary code for number 2, and it's this, 0, 0, 1, 0. It has its own binary code for our number 5, which is 0, 1, 0, 1. It has its own binary code for the number 9, 1, 0, 0, 1. Can you see how there's little 2's going down the side? That means base 2. So computers use base 2 binary code. We use base 10 numbers. Big difference. So if I wanted a computer to understand the number 5, this is a code which a computer uses to talk and communicate and understand that it's number 5. What we're going to do today in this video is get you to have a look at a binary code. So let's imagine right now, let's go back. Let's imagine right now that you 11 do not have access to this binary code here, to our base 10. I'm going to give you the task where you've got to turn this binary code into a number, which we use every day, into a base 10 number. That is what we're going to work on. So that if I said to you, what is 0111, you're going to be able to work it out and say to me, it's the number 7. If I say to you, what is the binary code 1000, you're going to say to me, it's the number 8. And we're all going to live happily ever after. Let's give it a go. Okay, before we start turning binary numbers into base 10 numbers, I'm going to give you a little challenge. Look at this pattern. We've got the number 1, we've got the number 2, we've got number 4, we've got number 8. What's going to be the next number in this box? Then the next one, then the next one, then the next one. I'm going to give you a bit of time to work it out, so pause the video now. Okay, so it's quite simple. To get the numbers 4, for example, all we've done is we've got 2 and we times it by the power of 2. So remember, this uses base 2. So 2 times 2 is 4. To get the number 8, what we've done is 4 times 2 equals 8. So the next number would be 8 times 2, which is 16. The next one, 16 times 2, which is 32. The next one, 32 times 2, which is 64. And the next one, 64 times 2 equals 128. And these are called place values. So let me just write that out for you. Place values. And all we've done is we multiplied it. So we times it by 2, each number. And that is for binary code. So if I ever said to you, you're going to be using binary code today, or you need to use binary code, the first thing you need to do is write out these numbers, just like that. I'm going to take it away. And what I'm going to do is I'm going to ask you from memory and it has to be from memory. I'm going to start you on 1. Is to write in binary codes, place values. Do it in the same way I've done it, in like a table. But it doesn't have to be neat. Off you go. Okay, so at the moment I'm using 4 place values, 1, 2, 4 and 8. I've given you the binary code 0011. Your job is to turn it into a base 10 number, a number you can actually understand. So imagine you're giving it to your grandma. I want your grandma to be able to understand the number. If you said to your grandma, hey Gran, what is 0011? She's not going to have a clue, unless she's some sort of computer genius. So we need to do the converting for her. And it's dead easy. What we do is we go through these columns, and every time there's a 1, we're going to write down the number, the place value number. So for example, is there number 1 in a place value of 8? No, there's not. So I'm just going to move on to the next one. Is there number 1 in a place value of 4? No, there's not. Move on to the next one. Is there number 1 in the place value of 2? Yes, there is. So I'm going to write down the number 2. And then I'm going to put an add. Is there a place value? So is there number 1 in the place value of 1? Yes, there is. So let's add them together, 3. So 0011 actually is 3 using base 10, our number system. So let's do another one. Let's do 111. So 0111. So is there number 1 in the 8 place value? No. So I'm just going to move on to the next one. Is there number 1 in the number 4 place value? Yes. So I'm going to do the top number. Is there number 1 in the number 2 place value? Yes, there is. Is there number 1 in the 1 place value? Yes, there is. So 0111 actually is 7. I'm going to give you 2 to do by yourself. I want you to work out what is 1111. And the next one I'm going to ask you to do would be this one. 1 0 1 0. See if you can work those ones out. So I want you to turn that binary code into denary. Off you go. So the answers. Okay, let's have a look at the first one. 1111 should be 8 plus 4 plus 2 plus 1. $15. The next one. 8 plus 2, which equals 10. So these binary codes equal 15 and 10. Okay. What you see in front of you. Okay. So, new fact. Each one of these is called a bit. So let's change it color for each bit. Let's do yellow, let's do green, and let's make the last one pink. What I'm going to do is I'm just going to get rid of the binary code. I want you to make 8 bits. So continue this little table so that it's 8 bits instead of 4 bits. 1, 2, 3, 4 bits at the moment. I want it to be 8 bits. Think back to the start of the video where we use the calculator. Pause the video and then compare it to mine when you're done. Good luck. Okay, so what you should have had next would be 16, 32, 64, 128. Remember, you're multiplying it by 2 each time. So right now, we have 8 bits. 1 bit, 2 bit, 3 bit, 4 bit, 5 bit, 6 bit, 7 bit, 8 bit. So let's have an 8-bit binary code. 1, 0, 1, 0, 0, 0, 0, 1. I would like you to turn that into a base 10 number using the same method as before. Pause the video, give it a go. Okay, what you should have had was 128 plus 32 plus 1. If you can't work that out yourself, my advice is to use a calculator. So let's do it by calculator. 128 plus 32 plus 1 is 161 as base 10. So 161 in binary code is 101,000,001. I'm going to give you another one. 11111,000,000,000. Solve that. Pause the video, give it a go. Okay, what you should have got was 128 plus 64 plus 32 plus 2 plus 1. So yet again, if you can't work that out yourself quick enough, use a calculator. So we've got 128 plus 64 plus 32 plus 2 plus 1 equals 227. Okay, so what we've been doing is we've been taking our binary code and turning it into base 10 numbers. And remember, base 10 numbers, it goes up to 9. It goes up to 9. And then after 9, what happens is it starts to repeat itself using the same number symbols again. So after 9, it will go 10, 11, 12, 13, which is fine, but we're just repeating symbols again, and that is base 10. It goes up to 9, in 0 to 9. But remember, computers don't understand base 10 numbers. They only understand binary code. What we've done is we've taken the binary code and we've turned it into base 10 numbers. What we're going to do next is simple. We're going to do it the other way around. We're going to take a base 10 number and turn it into binary code, and that is the next video.